Okay, good afternoon, everyone. So today we will begin a new module for Math 101. So last week we talked about propositional argument. So we talked about how we take propositions together and try to see if these propositions comprise a valid argument. When we say a valid argument, it is a series of propositions consisting of uh, premises and a conclusion. The premises are the first few, or the first few propositions in the series, and the last one is the conclusion. And when we say validity of an argument, we are testing whether the conclusion follows from the premises. Again, it is not a, it doesn't necessarily require to be sound, kasi yung mga valid arguments, our test is on the structure of the argument. So we want to see if assuming the proposition, assuming the premises will conclude or will give us the conclusion. So laging ina-assume natin na true yung mga premises, papakita natin na nagfa-follow yung isang true conclusion. In the same token, we say an argument is invalid if true premises will imply a false conclusion, or there is a chance that even if the premises are true, the conclusion will remain to be false. So basically, yun yung ginawa natin last time. And these arguments are comprised of propositions, right? Propositions in general. Now, for this week, we'll be talking about predicate calculus. So we will dig deeper into the structure or the inner structure of propositions. Kasi yung propositions natin dati ay isang statement na nag-work as if sa buong, sa lahat ng objects sa isang universe of discussion. Diba, sinabi natin na if all fish, ano nga ba yung example natin last time? If it is a fish, then it is a mammal. So meron tayong proposition dati na ganon. So meaning we are claiming that if a certain animal is a fish, then it follows directly that it is mammal. So it is it is kind of a generic statement. So it works for all fishes na kung fish siya, magka-follow na mammal siya. Pero we can give more inner structure into these propositions to make them more specific. And the result of these are predicated propositions. So yun yung pag-uusapan natin ngayon. So I have here the week 3 study guide. So our objectives are the following. So please try to get these skills kasi dito namin kayo itetest. Number 1 is to determine the truth value of propositions involving one or more quantifiers, and then translate quantified statement into symbols, translate informal statements into formal statements and vice versa, and provide the correct negation of quantified statements. So hopefully today we'll tackle the first 3 learning objectives. So, and then let's have the other one on Friday. Okay. Now there are 4 topics involved in this study guide, or 4 topics for this week. So here are the questions that we'll try to answer along the way. What are the different forms of quantifiers? How do we determine the truth value of a proposition with quantifiers? How do we translate informal mathematical statements into formal ones and vice versa? How do we properly negate statements involving qualifiers? And ano pa ba? Ito pa yung marami. Essentially the same questions as above, pero merong multiple quantifiers involved. So probably we'll tackle topics 1 and 2 today, and then topics 3 and 4 on Friday. Okay, so we will cover pages 25 to 36 of the work text. So nilagay ko siya dito sa aking slide, o sa aking PDF. So, okay. But at the end of the study guide, you'll see worksheet number 3. It is due on October 4th, right before midnight. So you can spend the part of your laboratory sessions on Monday to ask for help or guidance from your lab instructor regarding this worksheet. So and then again, if you'll have some problems meeting this deadline, just let me know. Email nyo ako and then CC yung lab instructor, or just a message via Teams or via Canvas would be fine. And then we'll see what we can do for you. But don't hesitate to ask for extension if you really need one. Okay. Okay, so for today, as I've mentioned, we'll be talking about predicate calculus. Ano nga ba yung predicate calculus? First sentence of this section tells us that predicate calculus is the part of logic that deals with the inner structure of propositions. So ina-analyze natin yung subject-predicate structure ng isang proposition. As I mentioned before, ang propositions natin last time ay parang napaka-generic. It works for all species under consideration or all objects under consideration. Now, we can specify saan lamang nag-work yung mga propositions. Kaya nagkakaroon na tayo dito ng subject-predicate structure dun sa propositions natin. Okay? So now, we will not just look at simple propositions as we have seen in previous topics, but now we will have propositions with several parts. Specifically, they may contain 3 parts. And what are these 3 parts? The first one is the term or the subject. So, or siya yung simuno ng pangungusap. So this is what is being described by the proposition, or dito nag-a-apply yung isang proposition. Now, the term could be a variable or a constant. Pwedeng sabihin na lang natin halimbawa, Jose Rizal is a national hero. So this proposition is a hero. This proposition is very specific. It only applies to Jose Rizal. So you can think of the term or the subject of this proposition to be Jose Rizal. In contrast to saying all Filipinos are national heroes or are heroes, na napaka-generic nung subject, right? But now we can specify these, and these propositions can also be a variable. Pwede nating sabihin X is a hero, okay? So where X can take some values that we can assign later. So the thing is, the term is what is being described or what is the subject of the proposition. So if we are using variables or we are putting placeholders into our proposition, we usually use the letters X, Y, and Z, small case, yung mga nasa latter part ng alphabet. Pero if we are dealing with constants and we try to symbolize them, we use the first few letters of the alphabet in lowercase, so A, B, C. But actually, we won't be strict about it. So hindi ko naman pina-follow yung conventions na to, pero these are common conventions. So that's fine if you follow them or not. At least be consistent and sana clear in context kung ano yung mga variables na ginamit. Okay? Siyempre, hindi kompleto ang isang sentence kung meron ka lang subject. Dapat merong predicate na nagde-describe dun sa subject. So sa pangungusap, meron kang simuno at panag-uri. So ganun din sa propositions. But in logic, medyo broad yung treatment natin sa predicate o yung meaning natin for a predicate. So sa sentence structure, yung predicate, siya lang yung remaining part of the sentence aside from the subject. Pero dito sa logic, the predicate is the actual sentence that contains a number of variables or a number of terms that claim something about, meron siyang multiple variables, multiple constants, or multiple subjects, and a claim about these subjects. So, ibig sabihin, yung actual meat ng proposition, siya yung predicate. So, this describes the subject, right? And usually they are denoted by the statement P of X, or a predicate involving or describing or claiming something about the variable X is usually denoted by P of X. So, pag sinabi natin Jose Rizal is a hero, yung buong sentence na yon, siya yung predicate. Alright? So it is pwedeng isama yung term dun sa predicate. So it means na, or when we try to symbolize it, kasama talaga yung term. So pwedeng P of A, where P is the claim that A is a national hero or is a hero. Okay. Now, so ito yung buong proposition. Including, or it could also include the term being described. And if the term to be described or the subject of your predicate is a variable, then the set of all permissible values for that variable is called the domain of the predicate. So, kung ano yung mga pwede mong i-substitute dun sa variable X na nandun sa loob ng predicate, so yun yung tinatawag na domain. Parang katulad din ng domain ng functions that we know from algebra, right? So sila yung mga pwede nating ipang substitute dun sa x. So if p of x is my predicate that x is a hero, then x will come from, say, the set of all Filipinos, or set of all living persons, or set of all dead persons. So parang ganon. So ikaw yung pipili ng domain ng predicate variable. Okay? Now, predicates can also involve multiple variables. So pwede siyang p of x1, x2 until xn, which is claiming something is true for x1, x2 until xn. And each of these exabytes can come from different sets. So posibleng si x1 manggagaling sa big A1, si little x2 pwedeng manggaling sa big A2, si little xn pwedeng manggaling sa capital AN. So posibleng maraming terms or subject dun sa isang predicate, and then this can come from different sets. That's why sometimes it is important to really explicitly state what is the domain of the predicate variable. Okay. Now, some examples. Illustration 1. We let p of x be the statement that x is a mathematician. So this is a predicate, x is a mathematician, and then we usually denote it by p of x. Si p yung statement, right? Ito yung p. And then kung ano yung subject, siya yung nilalagay nating predicate variable. So x is a mathematician and it is a one-place predicate. And then you can say the domain of p of x is the set of all human beings. Right? So ibig sabihin, pwede tayo mag-substitute ng kahit anong value ni x. It doesn't matter if the statement will become true when we plug in a certain value for x. It's another question. It's a question about the truthfulness of that proposition or the truth value of that predicate. Pero lahat ng posibleng nating i-test, pwede nating ilagay kay p. So you can say x can be replaced by René Descartes, and probably the truth value of p of x will be true. Or if you say Charles Darwin equals x, then p of x is false. Kasi hindi naman mathematician by profession si Charles Darwin. Okay. Now, an example of a multivariate predicate is example B. So we let x, y, z and be integers. So x, y, and z, these are the variables that will become the terms or the subject of our predicate. And then our statement P about x, y, and z is that x plus y plus z is equal to 5. Now, in this context, ang domain ng predicate P would be z cubed, which is basically z cross z cross z, kasi yung x, y, and z, they are all coming from the set of integers. It just so happened that they come from the same set, pero more generic propositions will not require them being from one set. Okay? Pero dito nagkapare-parehas lang. So this is a three-place predicate because we have three variables in it, x, y, and z. And then again, you can choose any triple consisting of integers to be your subject. Say we let x be equal to 1, x equals 4, and z equals 0. Okay. And then when you plug that into P, right, so we'll get 1 plus 4 plus 0, that's equal to 5. Then the proposition P of 1, 4, 0 is true, right? But then again, the values of the variable did not make the predicate true. Kasi pwede rin naman na ang triple kung gamitan ay 1, 2, 3. Kasi yung 1, 2, 3 ay triple din ng integers. But when I plug in 1, 2, 3 into my mathematical sentence here, I'll get 1, 2, and 3. I'll get the sum equal to 6. So the statement now becomes false. So P of 1, 2, 3 is false because it doesn't make, this triple doesn't satisfy the equation given in the proposition P or in the predicate P. Okay. So yeah. Any questions? Puro terminologies pa lang naman, no? But let me know if you want some things to be clarified. So let's see example 2 here, or exercise 2. So P of x coming from the set of real numbers. So R would be our domain for the predicate is the set of all real numbers. Our statement P about X is X squared greater than X. And then here you are asked if P of 2, P of 1/2, and P of -1/2 is true or false. So anybody want to answer? Ano yung, what's the truth value of P of 2? Okay, go Crizel.
P of 2 po is true because if x is equals to 2, then magiging 2 squared po is greater than 2, which is 4 greater than 2. So P of 2 po
Okay.
is true.
All right, thank you, Crizel. That's correct. So you'll get 1 point for recitation today. And then, oh yes, John Raphael.
Yung next na po ba, yung 1/2?
Yung next na, P of 1/2.
P of 1/2 po ay false because pag square po yung 1/2, it is equal to 1/4. And 1/4 is not greater than 1/2.
Okay, great. So P of 1/2 is true. Okay, Perlene, I saw your hand is raised. How about P of -1/2?
False po, sir. Since -1/2 squared is equal to 1/4, which is less than the... true po, sorry.
Okay, good. Okay, good catch there. So magiging true siya kasi 1/4 greater than -1/2. Tama? Okay, thank you, Perlene. Okay, so we see here that kasi kung dati yung proposition lang katulad dati, x squared greater than x lang yung proposition. So meaning we are claiming this to be, or we are checking whether this is true or false for all real numbers, okay? Pero ngayon napaka-specific na natin. Medyo meron ng inner structure yung kino-consider natin na propositions. So for those who recited, please drop in the comments dun sa chat na nag-recite kayo verbally para dun ko na lang itatali yung points nyo later. So and then, dahil nakasagot na kayo, yung iba naman na magsasagot later. Okay? So, yeah. Kailangan ko kasi ng time para enjoy yung kape ko habang nagtuturo. So kailangan kong kayo yung magsalita from time to time. Okay, so I promised 3 parts for a predicate, or for the type of propositions that we'll be talking about right now. So ito na yung third part. The last constituent of a proposition is called a quantifier. So yung quantifier ang nagsasabi sa atin na para sa ilang elements ng domain natin kine-claim yung predicate to be true, especially if your predicate has a variable on it. So there are 2 types of quantifiers. We have a universal quantifier and an existential quantifier. So when we say universal quantifier, these are the words or the phrases for every, for all, for each, given any x. And as the name implies, when you claim something is true with a universal quantifier, or when you say i-quantify ko universally yung statement o yung predicate na p of x. Now you are claiming that P of X, or the statement P about X, is true for every element of the domain. Kaya universal yung tawag sa kanya. And we use this notation, the inverted A notation, para sa universal quantifier. So ang base sa kanya ay for all, minsan for every, minsan for each. So here we say for all X in A, for all X in the domain A, the statement P about X is being claimed. Right? So, or minsan dinadrop na nga lang yung for all kasi sa math ang default natin ay when we say something is true, when we don't qualify it or we don't quantify it, laging parang generic yung claim, or the claim will be true for everything in the set of consideration. So minsan dinadrop na nga lang yung for all. But I find it easier to be very specific about statements that we make. So try to write for all whenever you want to claim a statement is true for every element of the domain. So let's make use of the universal quantifier. Okay. Now an example is in example 3. Okay. So we have 2 predicates here, or we'll be dealing with 2 two predicates. The first one is statement R about X, which will stand for X is a real number. And the statement Q about X is a rational number. Okay. So when you want to say for every X, X is a real number, so you simply write for all X, R of X. Okay. Or if you want to say that given any X, X is not a real number, so you can write it as for all X, not R of X, right? Or pag tinranslate nyo kasi to into words, for every X, it is not the case that R is a real number. So pwedeng literal yung translation, pwede rin namang hindi. You can go a little bit further and use synonyms. So kasi kung literal nga, kung parang Google Translate yung gagawin nyo, magiging ano to, for all X, it is not the case that X is a real number. Or you can just say for all X, X is not a real number. Okay, and these are universally quantified, meaning we are claiming this is true for all X's, for all possible values of X, for all permissible values of X. All right. Now, question is, when do we consider a universally quantified predicate to be true? O ano yung truth value niya? Or paano natin itetest yung truth value ng isang universally quantified statement or predicate? Now, that is what is in definition 4. We say that a universal statement is true if it is true for all X in A. But of course, this intuitively makes sense kasi you are claiming that statement P is true for all X's in the domain. So in order for this predicate, this universally quantified predicate to be true, so dapat totoo siya sa lahat ng elements ng domain. So medyo mabigat yung proof ng truthfulness ng proposition na to kasi kailangan mong i-test lahat ng posible nating i-substitute dun sa variable, dun sa predicate. Now, it is much easier to disprove or to say that a universally quantified statement is false. Kasi magiging false siya pag kahit isang element ng domain yung P of X ay naging false. So if you can find at least one element of your domain for which the predicate becomes false, then the universally quantified predicate becomes false. And that one example is called a counterexample. So enough na yon to prove the falsity of a universally quantified statement. Okay. Now, let's see some example. So illustration 5. So the domain here is specifically stated to be the set 1, 2, 3, 4, and 5. Now, we are asked to check the truth value of this predicate. Universally quantified siya. So because we are claiming that for all X in A, X is greater than or equal to 1 over X. So if we want to check, well, plug in these values for X. So if I plug in X equals 1, 1 greater than or equal to 1, that's true. Plug in 2, 2 greater than or equal to 1/2, that's true. 3 is greater than or equal to 1/3. 4 is greater than or equal to 1/4. And 5 is greater than or equal to 1/5. Since this statement is true when I replace all X's by all elements of A, then we say that this universally quantified statement is true. Okay. However, when we enlarge the domain as what was done in example B, the domain was now set to the set of real numbers. Now, mahirap exhaustively i-plug in lahat ng real numbers, but luckily, if you are clever enough, you can find one value for X for which the statement becomes false. And as the illustration suggests, we can take X equals 1/4. Because when we plug in 1/4, we will have 1/4 greater than or equal to 1 over 1/4. But 1 over 1/4 is equal to 4. And this is false, right? So here we have found one specific value for X for which the statement becomes false, right? Namely, X equals 1/4. And that is enough to invalidate or to make the universally quantified statement to be false. Okay, kahit isang counterexample lang. And counterexamples often are not unique. So each one of you can give different counterexamples to a certain statement. Kung false yung universally quantified statement. Okay? Okay, let's try this one. Exercise 6. So here we have a universally quantified statement. For all x in the domain D, root of x is less than or equal to x. And then let's try. Totoo ba, true ba itong universally quantified statement? In case A, wherein your domain is the set 0, 1, 2, 3, or 4. Yes, Kit? Ang bilis ah. Go ahead, Kit. Kit Neil. Then si Ila Z yung susunod. Hello, Kit. Naghang ba yung connection ko or di pa nagsasalita si Kit? Okay, thank you, Kit. Okay, true daw siya, sabi ni Kit. Yes, because if you plug in 0, 1, 2, 3, and 4, isa-isa sila dito sa statement na to, then we get a true statement. Okay? Oh, it's okay, Kit Neil. Yeah. So, sumagot ka naman via chat. Okay, that's good. Now, I think the next one is, sino yung tinawag ko? Si Ila.
Yes po, sir.
Okay. How about
So,
when I enlarge the set D into R?
So, false po kasi may pinili po ako isang number, say for example, -1. Then, plotting it sa sa na condition, magiging 1i is less than or equal to -1.
Tapos less than or equal to?
-1, which is false since magiging complex number.
Okay, probably I can accept that. Though meron technicalities dun sa argument kasi ang problema, hindi defined yung less than relation sa set of complex numbers. So hindi ko pwedeng ma-compare si I kay -1 kasi walang ordering, hindi defined yung less than or equal to sa set of complex numbers. Okay? So, kaya medyo may fine line dun sa argument na yon kasi I cannot compare I with -1. There's no such less than relation for the set of complex numbers. But I think I know what you're trying to hint at. Pero can you give another example na yung left hand ng inequality ay magiging positive? Sorry, magiging well-defined. Ila? And then si Trisha yung susunod.
Yun lang po sir yung ko po, yung na-observe ko po.
Okay, yeah, no problem. Yeah, but I guess you're right. You're trying to see to seek a counter example. I guess it's Trisha who raised her hand first kanina. So
yung ginamit na rin pong value ng x sa last example, yung x equals to 1/4 po. Kapag in-square root yung 1/4, magiging 1/2. So,
okay, so magiging 1/2 less than or equal to 1/4, which is false. Okay, great. Thank you, Trisha. Yeah, that's right. So yeah, you can think of several counterexamples to it. Ano pa ba yung posible? Actually, lahat ng numbers less than 1, tama ba? Pwede siyang syempre between 0 and 1 will be a good counterexample. Okay, thank you. Okay, let's try illustration 7. Now, we'll be working with the same predicates R and X from before. Statement R about X is a real number, and statement Q about X is a rational number. Now, dun sa translation natin later, madalas encounter tayo ng mga if-then statements. But however, these if-then statements are not usually written in the usual if-then structure ng conditional statements. Kaya minsan medyo tricky yung pagta-translate sa kanila. So for instance, look at example A. When we say all rational numbers are real numbers. So bago natin siya ma-translate symbolically, kailangan i-analyze muna natin yung statement. So hindi literal yung pagkaka-translate nito into mathematical sentence or into symbols. So all rational numbers are real numbers. So what is this statement trying to tell us? It is trying to tell us na kapag ka-rational number siya, automatic na nagiging real number siya. Tama ba? It is saying that all rational numbers are real numbers. So, ibig sabihin, kung rational siya, magfa-follow dapat na real number siya. Okay? Now, that's why it can be translated into a more detailed English statement like this. For every x, if x is a rational number, then x is a real number. And this more detailed statement is easier to translate into symbols. So for every x, we get this for all x in symbols. If x is a rational number, so if is the, what do you call this? This is the indicator that the next phrase would be your precedent or your antecedent. X is a rational number, that would be, q of x. So yun yung antecedent. And then the then part signifies that whatever is to follow would be your consequent. X is a real number, but we said x is a real number is represented by r of x. So that's why this statement is translated in symbols as this one. For all x, q of x implies r of x. If it is a rational number, automatically it is a real number. And it follows, yeah. So ganun siya tinatranslate. Hindi ganun ka-literal yung translation. Okay. Meanwhile, look at example B. No rational number is a real number. So pag in-analyze nyo to, walang rational number na real number din. So there is no rational number that is also a real number. So ibig sabihin, kung siya ay rational number, hindi siya pwedeng maging real number. So that's why I can translate this first into a universally quantified predicate, right? So pwede kong sabihin na no rational number is a real number is the same as saying for every x, if x is a rational number, then it is not a real number. Because the statement originally says walang rational number na real number din. So kung siya ay rational number, automatic hindi siya pwedeng maging real number. And I guess this is a better lengthy English translation of this statement. But though it is lengthier, it is better for us because we can translate it easier. So for every x, correspond to the universal quantifier for all x. If, so this would be your precedent. X is a rational number, so that is q of x. Then, yun yung implication doon. Tapos ito yung consequent. X is not a real number, so it is not the case that r of x is true. Okay. Now, is statement A, or this first statement, is this true or false? Anyone? True or false ba yan? Trisha, pag wala na lang nag-raise ng hand na iba. Keith Neal, nakasagot na rin yata si Keith Neal. Tama nga ba? Oh, yes. Yeah. Other hands. Rian Pearl. Is this true or false? Go ahead, Rian. Okay, true. All right. Bakit kaya siya true? Well, actually, it makes sense, right? So, kasi ang set of rationals ay subset ng set of all real numbers. So, alam natin sa Venn diagram, kung ito yung rational, yung set of real numbers ay ito. So, kung real number siya, automatic na siya ay real number. Okay? So thank you, Rian. How about part B? Is this true or false? Anyone? Okay, statement B, true or false? Yes, Gabriel or Gabriel.
Gabriel po. False
Okay,
po, sir.
Gabriel. Come again, sorry.
Ay, sorry. False po.
Okay, false. Counter example. Can you give me a counter example?
Kunyari po, 1/2.
Okay, so your x is 1/2.
Ayun po.
So
If
si
x
1/2. Okay, go ahead.
If x is 1/2 po, tapos sinasabi po dun sa statement na dapat hindi siya real number. Pero 1/2 is a real number po. Therefore, it is false po.
Okay, thank you. That's perfect. So that's correct. So because again, the statement is claiming that this is true for all x. Pero Gabriel gave us a value for x. X equals 1/2. So si 1/2, alam natin siya ay rational number. So Q of 1/2 is true, right? True yung truth value niya. Implies not R of 1/2. Pero anong truth value ng not R of 1/2? So R of 1/2, ibig sabihin 1/2 is not a real number, which basically is false, right? So yung conditional statement na to, for the case of x equals 1/2, is or has truth value t implying false. And we know true implying false ay false. So therefore, we have found one example, namely 1/2, for which this universally quantified statement will be false. So that means this would be false. Okay? Ang saya pag false, no? Kasi makaisip ka lang ng isang example, then sufficient na yon. Pero kung gusto mong i-prove na totoo ang isang universally quantified statement, that's another thing. Because you need to show that it is indeed true for all elements of the domain. Yung mga examples natin kanina, madali kasi yung domain natin ay finite. Yung mga 0, 1, 2, 3, 4, and so on. Pero kapag ka infinite na yung set, or marami na siyang laman, hindi na practical na gumamit ng substitution or exhaustive substitution para malaman yung truth value ng universally quantified statements. Okay? Okay. Right, so we can move on to the second type of quantifier, and this is called an existential quantifier. Now, existential quantifier can take the form of phrases like for some, or for at least one, or there exists. So, and it is denoted by the mirror E. Parang naka-mirror yung E, nakabaliktad yung pagkakasulat. So, existential quantifier siya, meaning there exists an X in A. Existential, so kine-claim niya lang merong isang X na parte ng domain na totoo yung statement P about X. Okay? So, for instance, this in symbols can be read as there exists an X coming from A such that statement P about X is true. Okay? So, yeah. Existential, meron lamang at least isa. Okay? So, for instance, sa translation, example 9, ang predicate natin ay T, X is divisible by 3, and then S of X is X is divisible by 6. Yung naming ng mga propositions, it could be an arbitrary choice of variable, pero mas okay minsan kung kaya niyong bigyan ng meaning yung bakit yun yung pinili niyong variable. Halimbawa dito, pinili niya ng T of X yung mag-denote nung X is divisible by 3, probably because 3 starts with the letter T. Tapos dito S of X because 6 starts with the letter S. So para medyo madali siyang madaling i-analyze yung statements, lalo na kung mahaba yung argument o masyadong maraming involved na propositions. So mukhang okay na piliin yung variables na medyo related dun sa propositions for which they stand for. Okay? So when you want to say x is divisible by 3, or for some x, x is divisible by 3, you can write it this way. There exists an x such that t of x. Or if you want to say that x, or there exists some x such that x is not divisible by 3, you can write it this way. Okay? Now, minsan pag nagsusulat ako ng existentially quantified statements, minsan sinusulat ko siya na there exists an x such that, so s dot t stands for such that t of x. Hindi lang comma kasi parang weird sa akin yung comma lang. So kasi babasahin ko rin naman siya na such that. So lagay ko na siya dun sa symbols, st. Or sometimes I use the symbol for such that instead na st. Minsan ang gamit ko ay ito. So ang basa rin sa kanya is such that. So there exists an x such that t of x. So di ba mukhang pang matalino yung pagkakasulat ng statement. So you can brag about this with your friends na, oh, kaya mo bang basahin to? Right? Parang elementary lang yung datingan eh, no? Pero yeah, we can be petty sometimes. Hold on, guys. Okay, now, next question is, when is an existentially quantified predicate true? Well, we'll have definition 10 answer that for us. An existential statement is true if it is true for at least one x in A. So, para ma-prove yung isang existential statement or para ma-conclude na siya ay true, kailangan lang magbigay kayo ng isang element ng domain na nakaka-satisfy ng statement P. After all, it makes sense kasi yung existential statement lang naman ang sinasabi niya, there is at least one or there exists one element of the domain such that P of x. So, enough na proof na magbigay kayo sa akin ng isang element ng domain for which P of x becomes true. And that will make the existentially quantified statement to be true. So isa lang, makapagbigay kayo ng isang example, proof of existence na yon. Okay? So and that would be good enough. Now, it is a little bit harder to prove that an existentially quantified predicate is false. Kasi kailangan yung ipakita na walang element ng domain na nakakasatisfy ng statement. Right? Or it would be false if it will not hold for all elements of the domain. Kaya medyo mas mahirap siya kesa sa proof of truthfulness ng isang existential statement. So let's try illustration 11. Okay. Now, case A. We let A to be the set of integers. Aga naman ni Prince magtaas ng kamay. So, okay, Prince, I'll let you answer this. Show that the following statement is true. There exists an m in A such that root of m is equal to m. So here you're saying that it is what? You're saying this is true dahil kay 1. Tama ba, Prince? Dapat pagsasagot kayo specific. Okay, so yan. So please tell me first, what is that 1 for? So you are claiming that this is true. So ibig sabihin, true siya. So ang example niya ay 1. Because when you plug in m equals 1, root of 1 is equal to 1, then that's enough. So dahil existence lang naman yung kiniklaim ng statement, so saying that m equals 1 will make this statement true will be enough. So true yung existential statement. Okay, anybody else? Can you give me an example to prove that this is true aside from 1? Anybody aside from Prince? Oh, yes, Jasmine.
0 po.
Okay, great. 0 is another example because m is 0 is an integer, so that means it belongs in the domain, and then square root of 0 is equal to 0. So that's great. So yeah, so this is true. How about statement B? Okay. So it says pinaliit yung domain. Ang domain ko na lang ngayon ay 2, 3, 4, 5. Is the statement true or false? Anybody aside from those who already answered? Taas muna ng kamay bago mag-chat para may chance lahat or yeah. Anyone? Is the existential statement true or false? Same statement. Ito pa rin yung statement. Pinaliit lang yung domain. Yung domain lang ay set 2, 3, 4, and 5. Oh yes, Neil Christian. Baka nauna si Neil Christian.
Sir, po,
Next
sir.
question ka na lang, Dino.
False po siya kasi kahit anong i-substitute mo po sa 2, 3, or 4, 3, 2, 3, 4, 5 po sa dito po sa square root of m equals m po, wala pong magiging true po, sir.
Okay, great. Thank you, Neil Christian. That's correct. Kasi kahit ano yung i-substitute mo dun sa m, coming from the set 2, 3, 4, 5, walang magpapatrue dun sa statement. Dahil napakita na natin na kahit anong element ng domain, i-plug in mo dun sa statement, laging false. So that makes this existential statement false. Okay? So usually the truthfulness or falsity of quantified predicates also depend on the domain. So be careful kapag may in-specify na domain. So kailangan dun nyo siya itetest or with respect to that domain. Sometimes the domain will be given explicitly, or at least most of the times it will be given. Pero kapag ka inomit yung domain, hindi binanggit yung domain, by default, imagine it to be as generic as possible. So halimbawa, meron akong statement about numbers, tapos hindi ko nabanggit yung domain, pwede nyo siyang i-consider to be the set of all real numbers, pinakamalaki ng posibleng set. Or halimbawa, meron akong statement about people, so pwedeng set of all human beings yung maging domain pag nakalimutan naming ilagay yung domain. Actually, mas madali yan para sa inyo kasi mas madaling maganap ng counterexample. So, yeah. Pero whenever, and we usually do that, we omit the domain if it is clear in context. Pero kung malabo sa context, kailangan talagang ibigay kung ano yung domain. Kasi as we have seen, the truthfulness and or falsity of a given quantified predicate depends on the domain being considered. Okay? Okay. Sige, Dino, you want to answer exercise 12? So sa exercise 12, ang domain ay set of all real numbers. And then the statement is there exists an x in A such that x squared is equal to -1. So why this statement is false?
Hello, sir.
Okay, go ahead, Dino.
Kasi po kapag plinag yung like all real numbers, lahat po ng square niya will not be positive, will not equate to a negative number.
Okay, thank you. Kasi kahit anong real number, yung piliin mo, pag kinuha mo yung square niya, nagiging positive, tama? So, impossible na magkaroon ng negative na answer, let alone maging -1. So, since you can argue that it is impossible that this statement will be true for any real number, then the statement is false. Okay? Pero kung nakita nyo, mabigat yung proof ng falsity ng existential. Kasi marami kang candidates. Kasi existence lang. So at least may isa dun sa infinitely many candidates na mag-satisfy ng statement, the statement will be true. Pero dahil na-argue nga ni Dino o ni Dino na imposible, so ibig sabihin ay false na yung existential statement. Okay? Before ko pala makalimutan, if you answered today, huwag niyong kalimutan verbally, huwag niyong kalimutang isagot dun sa chat, i-comment dun sa chat na nagsagot kayo kasi doon ko na lang siya i-record mamaya.
Counted po ba, sir, yung akin?
Counted yun, Trisha. Kaya hindi na kita tinawag nung so,
nawalan po kasi ng kuryente. Okay po.
Okay, yeah. Paki-comment na lang dun sa chat. And then, meron pala mga members ng, meron tayong, pag hindi yata member ng team ay walang access dun sa meeting chat, tama ba? So kung nagsagot kayo tapos hindi kayo makapag-chat, mamaya before we end, please let me know para ma-comment ko dun sa chat. Kasi dito ko itatali sa comment section yung sumagot. Okay? Now, maybe I'll end with example 13 kasi medyo time na. Let me borrow 2 or 3 more minutes. So, nag-work din yung quantified predicates even if you have a compound proposition or if you have a compound predicate. So, for instance, here we are considering yung kaninang statement, T and S. So, T about X is divisible by 3. S about X is divisible by 6. Now, if you want to say some numbers divisible by 3 are also divisible by 6. So, you can translate it into a more detailed English na there is, kasi sum yung ginamit. So, pag sinabing sum, mathematically, ibig sabihin at least may isa. Okay? So, sa English ba, pag sinabi nating sum ay ano yung implication? Parang pag sinabi nating sum ay, sa English parang ang intuition ay more than one. Tama nga ba? Pero sa math, clear tayo. Walang ambiguity. Pag sinabi mong sum, okay lang na iisa. Kasi yung isang case na yon, siya na yung sum. Alright? So when we say some numbers divisible by 3 are also divisible by 6, so that means there exists a number that is divisible by 3 and 6 at the same time. Or there is at least one number that is divisible by 3 and also divisible by 6. So now, it is a compound predicate kasi first statement, divisible by 3. Second is, it is also divisible by 6. So in symbols, you can write it this way. There exists an X such that P of X and S of X. Okay? And then yung test for truthfulness nito is again, finding a specific X that can make this compound proposition true. So, ang itinetest lagi natin ay yung proposition or yung predicate that follows the quantifier. So, kailan ba magiging true ito? Pero ito ay isang compound proposition. It is a conjunction. And remember, conjunctions are true if both conjuncts are true. So, medyo mabigat din to kasi dapat true yung T at saka yung true at saka true din yung S para dun sa X na pipiliin nyo para mapakita na ito ay true. So, can somebody give me an example that will make this true? Or actually, that would be the proof that this statement is true. Can you give me an X that will make this statement true? Okay, Jasmine, I think you went first.
We can choose 18 po to make the statement true.
Okay, X equals 18. Let's see. X equals 18. So on T of 18 means 18 is divisible by 3. That's a check. So true. Tapos S of 18. 18 is divisible by 6. True. True and true. That's true. So we have found at least one X. So therefore, this statement, this quantified statement is also true. Okay. Thank you, Jasmine. And then statement B, some numbers divisible by 3 are not divisible by 6. So when we translate this, there exists an X such that P of X, so X is divisible by 3, and it is not the case that X is divisible by 6. Okay, ang dami na naka-raise ng hand. Di ko na, siguro makikita ko yung order dito. Okay, sa lahat na nagtaas ng kamay, si Perlene na lang yata yung walang recitation points. Yes, go ahead, Perlene. Can you give me an example?
Kapag po pinlagin, sir, si 9 divisible by 3 but not
si 9?
divisible by 6. Apo.
Okay, now let's see. So X equals 9 daw, sabi ni Perlene. So T of 9. T of 9, 9 is divisible by 3, so that's true. 9 is not divisible by 6, so not S is true. True and true, that's true. Okay, great, Perlene, that's correct. And I guess Beatrice also tried to answer. Beatrice, meron ka ba naisip aside from 9?
Ano po, sir? X is equals to 15. Sir, X is equals to 15 po.
Sorry, Beatrice. X equals 15. Okay, thank you. Medyo malabo lang yung audio. Baka sa internet ka. But you're correct. X equals 15 is also a counter, is also an example. So they'll see 15, divisible ba siya, divisible siya by 3, pero hindi siya divisible by 6. So we have found another X. Pero again, sa existential, isa lang yung kailangan natin. So when Perlene suggested X equals 9, that's enough proof nung existential statement. Right? It's just a bonus that we found another X that is divisible by 3 but is not divisible by 6. Okay? So we'll end the discussion here. It was nice to hear from a lot of you. So sana ganito tayo lagi. Kailangan lang palang may bonus para magsalita kayo. Itatali ko na lang siya. Again, kung wala kayong, kung sumagot kayo verbally, pa-comment na lang sa chat na nagsagot kayo. Kasi doon ko siya itatali. And then, sino yung mga walang, hindi member ng team na walang access sa chat na nag-recite? Okay, Beatrice. Sorry, hindi ko pala alam yung mga ano niya, yung mga nicknames niya. Siguro next time or as we go along. Okay, Bea, Perlene, Neil Christian. Who else? Perlene, and then Jasmine. May nakalimutan pa ba ako? So si Bea, si Jasmine, si Perlene, si Neil Christian. Okay, and then okay, DJ. Okay, good. So yeah. Okay, so this was a fun meeting. At least hindi lang ako yung nagsasalita. So hopefully we'll keep this going till the end of the semester. So thank you guys for coming to. Before that, any question bago yung closing spiel ko? Any questions? Wala naman. So I think everything is clear. Medyo light nga lang yung discussion natin ngayon. It's just translating and some bunch of terminologies. But okay. So, John Raphael, do you have a question?
Sir, may question po ako. What if paano po namin mapoprove na true kung sakaling hindi po kasing dali, kunyari po yung universal statement
sorry,
po.
JR, hindi ko, baka may problema yung audio ko, pero nakita ko na yung chat. So, yeah. Okay, Ila also submitted. Tama ba Ila ang pronunciation ng Ila?
Yes po.
Okay, thank you. Tapos ito pala, before I forget, di ba meron tayong problem set 1.1? So, kung yung argument na napili nyo in media ay may existential, ay pwedeng magkaroon ng pwedeng nyo siyang i-translate with an existential quantifier. So, pwede nyo gamitin yung mga discuss natin ngayon na tools para dun sa problem set 1.1. Tapos, pwede kayong mag-antay hanggang ma-discuss natin yung validity or invalidity ng existentially ng quantified predicates para dun sa pagsasubmit nyo ng problem set 1.1. Anyway, the deadline is sometime October pa naman, so we still have time for that. Pero okay lang din naman na propositional argument lang yung ibigay nyo. So it doesn't matter. But if your chosen media presented a quantified or an argument involving quantified predicates, then that's also good. So pwedeng antayin nyo na lang yung ma-discuss natin yung validity ng predicated, ng quantified predicates para mag-submit ng problem set 1.1. Okay? So and with that, I enjoyed our class today. Hopefully we'll keep it up until the end of the semester. Thank you guys for coming today. Enjoy the rest of the evening. And let's see each other again on Friday. Bye, everyone.
Thank you po.